This is pre-algebra lesson 4-1, divisibility in factors. Something is divisible if the remainder is 0 if one number is divided by another number. For example, 12 is divisible by 6, because 6 will divide into 12 2 times with a remainder of 0. A factor is an integer that divides another non-zero integer with a remainder of 0. So if I said name the factors of 12, factors of 12, 12 can be divided by 1 and 12, 2 and 6, 3 and 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. They are all the integer numbers that divide evenly into another number. Now, I'm often asked if something is divisible by something else. I can answer those questions fairly quickly because I know the divisibility rules. The divisibility rules are an easy way to know whether or not another number is divisible by a specific number. For example, an integer is divisible by 2 if it's an even number, which means it ends in a 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of its digits is divisible by 3. A number is divisible by 4 if the last 2 digits are divisible by 4. A number is divisible by 5 if it ends in a 0 or a 5. A number is divisible by 6 if it's also divisible by 2 and 3 at the same time. For example, 12 is divisible by 6 because it's divisible by 2, and 12 is divisible by 3, so I know it's divisible by 6. A number is divisible by 9 if the sum of the digits is divisible by 9, and a number is divisible by 10 if it ends in a 0. Now, there are divisibility rules for 7 and 8. They are very complex and rarely used. I don't use them, but if you'd like to know what those divisibility rules are, I have a poster in my room which will tell you if a number is divisible by 7 or 8. We're going to focus on 2, 3, 4, 5, 6, 9, 10. Let's see if the first number is divisible by the second number. Let's explore. Is 1028 divisible by 2? Well, the divisibility rule for 2 is if it ends in a 0, 2, 4, 6, or 8. Since it ends in an 8, this number is definitely divisible by 2. Okay, it's divisible by 2 because it ends in an 8. How about 572 divisible by 5? Well, if something is divisible by 5, it ends in a 0 or 5. This is not a 0 or 5, so this would be no, because a number does not end in a 0 or 5. $275 by 10. Again, it's not divisible by 10 because it doesn't end in a 0. So it should be no, doesn't end in 0. All right. Now we're going to tell whether a number is divisible by 2, 3, 4, 5, 6, 9, or 10. The easiest way to do this is to systematically go through the number. Okay. Is it divisible by 2? No, because it doesn't end in a 0, 2, 4, 6, or 8. Is it divisible by 3? Well, let's find out. Okay. 4 plus 2 plus 8 plus 7. Okay, if we add that up, we get 21. That means yes, because 21 is divisible by 3, so this number is also divisible by 3. Is it divisible by 4? Now remember the divisibility rule for 4 is that the last 2 digits are divisible by 4. Nope, because 87 is not divisible by 4. It's not divisible by 4. Is it divisible by 5? No, because it does not end in a 0 or a 5. Is it divisible by 6? Well, it's not divisible by 2, but it is divisible by 3, so it cannot be divisible by 6. In order to be divisible by 6, it has to end in a 2 and a 3. Okay. 9 is divisible by 9. Product again is 20, or the sum is 21. Okay, so that's no, because 4 plus 2 plus 8 plus 7 equals 21, which is not divisible by 9. And is it divisible by 10? No, because it doesn't end in a 0. Okay, so if I said, tell what numbers it's divisible by, you say, oh, it is divisible by 3. And that is it. Let's look at 174. I'll do a different color so we can stand out a little bit. It's divisible by 2, yes. Because it ends in a 0, 2, 4, 6, or 8, it ends in 4. Is it divisible by 3? Yes. Because if I look at 1 plus 7 plus 4, that equals 12, it is divisible by 3. Is it divisible by 4? No. 74 divided by 4 doesn't work. Okay. Is it divisible by 5? No, it doesn't end in 0 or 5. Is it divisible by 6? Yes, because it's divisible by 2 and 3. Since it's divisible by both 2 and 3, it is divisible by 6. Is it divisible by 9? Okay, no, because the sum 12 is not divisible by 9. And is it divisible by 10? No, because it does not end in 0. This number is divisible by 2, 3, and 6. 43,542. Is it divisible by 2? Yep. Because it ends in a 2. Is it divisible by 3? Let's see here. 7 plus 5 is 12 plus 4 is 16 plus 2 is 18. So yes. If I add those digits up, 4 plus 3 plus 5 plus 4 plus 2 equals 18, which is divisible by 2. Or excuse me, equals 3. Is it divisible by 4? No. Because 42 is not divisible by 4. Is it divisible by 5? No, that's not in 0 or 5. Is it divisible by 6? Yes, because it's divisible by 2 and 3. Is it divisible by 9? Yes, because 18 is divisible by 9. Is it divisible by 10? No, because it doesn't end in 0. Right, so you can quickly go through without having to actually divide the number out. You don't have to take 43,542 and divide it by 9 to see if it's evenly divisible. You just have to know the divisibility rules. It's very helpful if you know those divisibility rules. That will speed up your mathematical processes greatly, especially when simplifying fractions. All right, let's list the positive factors of each number. The easiest way to list factors, I like to just think of dividing it by the smallest number first, and I like to work in a table. I know that 10 is divisible by 1 times 10, and 2 times 5, and it's not 3 and it's not 4, and we already got the 5, so my factors are 1, 2, 5, and 10. 21, I know that's 1 times 21, not divisible by 2, that's 3 times 7, it's not divisible by 4, it's not divisible by 5, and it's not divisible by 6, so I'm done. So my factors are 1, 3, 7, and 21. You always list the factors in order from smallest to largest. 24. That's 1 times 24, and 2 times 12, and 3 times 8, and 4 times 6. Okay, and it's not 5 times anything, and I'm done because I already know I go 1, 2, 3, 4 going down, and 5, 6, 8, 6, 8, 12, 24. So I know since these two numbers are really close together, the only other number that could be divisible by is 5, and if it's not, I know I'm done. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So those are the factors of 24. Okay. You can use all these divisibility rules and factors to solve a multitude of mathematical problems. We'll stick right now with just being able to tell whether or not a number is divisible, and by using those special rules.